Hi, welcome back to the channel. An engine misfire is a common yet concerning issue that can affect a vehicle's performance, fuel efficiency, and longevity. The problem becomes more noticeable when accelerating as the engine demands greater power. This phenomenon often manifests as hesitation, shaking, or sudden power loss, alarming the driver and potentially compromising safety. Understanding the causes, identifying the symptoms, and implementing the appropriate solutions are essential to maintaining a well-functioning vehicle. An engine misfire occurs when one or more cylinders fail to combust the air-fuel mixture properly. This imbalance disrupts the engine's power output and smooth operation. During acceleration, when the power demand is at its peak, the issue is more pronounced because the engine is unable to deliver consistent performance. Misfires can range from minor annoyances to significant problems that may cause severe engine damage if left unresolved. Engine misfires when accelerating. Causes, diagnosis, and solutions. An engine misfire is a common yet concerning issue that can affect a vehicle's performance, fuel efficiency, and longevity. When accelerating, the problem becomes more noticeable as the engine demands greater power. This phenomenon often manifests as hesitation, shaking, or a sudden loss of power, alarming the driver and potentially compromising safety. Understanding the causes, identifying the symptoms, and implementing the appropriate solutions are essential to maintaining a well-functioning vehicle. What is an engine misfire? An engine misfire occurs when one or more cylinders fail to combust the air-fuel mixture properly. This imbalance disrupts the engine's power output and smooth operation. During acceleration, when the power demand is at its peak, the issue is more pronounced because the engine is unable to deliver consistent performance. Misfires can range from minor annoyances to significant problems that may cause severe engine damage if left unresolved. The causes of engine misfires during acceleration are diverse, spanning mechanical, electrical, and fuel-related issues. Spark plugs are integral to igniting the air-fuel mixture in the combustion chamber. Over time, they can become worn, fouled, or damaged, leading to incomplete combustion. During acceleration, the increased workload on the engine can amplify the effects of faulty spark plugs, resulting in misfires. Ignition coils convert battery voltage into the high-voltage electricity required to generate a spark. If an ignition coil malfunctions, the spark may weaken or fail altogether, causing misfires, particularly under the strain of acceleration. The engine relies on a precise air-to-fuel ratio to function efficiently. A vacuum leak caused by cracked hoses, gaskets, or seals introduces excess air into the intake manifold. This imbalance can disrupt combustion, especially during acceleration when precise fuel delivery is crucial. A clogged fuel injector, faulty fuel pump, or dirty fuel filter can impede the delivery of fuel to the engine. Inadequate fuel supply prevents the cylinders from combusting effectively, leading to hesitation or stalling during acceleration. Each cylinder in an engine requires adequate compression to ignite the air-fuel mixture. Damaged piston rings, leaking valves, or a blown head gasket can reduce compression, resulting in misfires that are particularly evident during acceleration. Modern engines rely on a network of sensors, such as the oxygen sensor, mass airflow, OBD-II sensor, and crankshaft position sensor, to regulate performance. A malfunctioning sensor can send incorrect data to the engine control unit, ECU, disrupting combustion and causing misfires. A clogged catalytic converter restricts exhaust flow, leading to increased back pressure. This condition can cause misfires by impairing the engine's ability to expel exhaust gases and draw in fresh air during the combustion cycle. Engine misfires are typically accompanied by noticeable symptoms. The engine may shake or vibrate excessively, especially when stationary. A sudden drop in power output during acceleration is a hallmark of engine misfires. Modern vehicles often illuminate the check engine light when a misfire occurs. Diagnostic trouble codes can be retrieved using an OBD scanner to pinpoint the problem. Misfires result in incomplete combustion, leading to higher emissions of unburned fuel. An engine experiencing misfires requires more fuel to achieve the desired performance, decreasing efficiency. Proper diagnosis is essential to address engine misfires effectively. The process generally involves examining spark plugs, ignition coils, and vacuum hoses for visible damage. Retrieving error codes using an OBD scanner. Common codes for misfires include P0300 random misfire and P0300 and 1P0308 cylinder-specific misfires. Measuring cylinder compression to identify potential mechanical issues. Inspecting fuel injectors, fuel pump, and filters for clogs or malfunctions. Testing critical sensors using specialized tools to ensure they provide accurate data to the ECU. The appropriate solution for an engine misfire depends on the underlying cause. Potential remedies include replacing spark plugs and ignition coils. Regular maintenance ensures reliable ignition and prevents misfires. Repairing vacuum leaks. Replace damaged hoses, gaskets, or seals to restore the proper air-to-fuel ratio. Cleaning or replacing fuel injectors. Periodic fuel system cleaning helps maintain optimal performance. Addressing mechanical issues. Repair or replace faulty components such as piston rings or valves to restore compression. Updating sensors and software. Replace malfunctioning sensors and update the ECU software if necessary. Preventive measures such as adhering to recommended maintenance schedules, using high-quality fuel, and conducting periodic inspections can minimize the risk of misfires. If you like this video, give it a thumbs up, share, and also subscribe to this channel for more informative videos.